Welcome to the lecture video for section 3.1 in Math 95. We're going to be talking about graphing equations. You can see the objectives. We're going to review how to plot ordered pairs, determining whether an ordered pair is a solution to an equation, and then we're going to talk about how to graph functions specifically from tables. So let's get started. This is a rectangular coordinate system. So on this grid, I've asked you to locate and label a few things. We want to label the origin, the x-axis, the y-axis, and then the quadrants. The origin, this word means beginning, so we want to look at where our graph begins, and I'm going to label that in red. We're going to call this the beginning. And a graph starts right here in the center of these two lines. These lines have a very specific name for each of them. The horizontal line is what we call the x-axis. It's the horizontal axis, and I'm going to label that with a little x. Now my x's look kind of weird, they're cursive, and otherwise they end up looking like multiplication symbols when I start doing my math. The y-axis I'm going to label in a different color. That is our vertical axis, and I'm going to label that with a y. Now, the origin I haven't labeled yet. I've marked it, but I haven't labeled it yet. How I want to label that is with what we call an ordered pair. An ordered pair tells me the x and the y location of a point. So this point right here is at the location 0, 0. It means I haven't gone anywhere for x and I haven't gone anywhere for y. I'm going to label that right here as well. In order to talk about where things are on the Cartesian coordinate system or the rectangular coordinate system, we sometimes like to refer to them by their quadrants. And so we want to label the 4 quadrants. These are going to go counterclockwise from the x-axis, the positive x-axis. So this is the positive x-axis on this side. This is the positive y-axis. This would be the negative x-axis, and this is the negative y-axis. So if I wanted to name this fourth of my graph up here, we're going to call it quadrant 1. And then going in a circle the opposite way that a clock would go, we're going to label the other quadrant. So this next one is quadrant 2. This one would be quadrant 3. And this one is quadrant 4. We use Roman numerals. I'm not exactly certain why, but that's how I've always seen them labeled, so I go with convention on that one. Notice in quadrant 1, both the x value and the y value would be positive. So a point up here would have a positive x value and a positive y value. In quadrant 2, we would have a negative x value and a positive y value. In quadrant 3, we'll have a negative x value and a negative y value. Both pieces are negative. And in quadrant 4, we'll have a positive x value and a negative y value. So just by looking at the signs in your ordered pair, you should be able to tell where a point will lie. Now that we've talked about the quadrants, I want us to label where these specific points will be on this graph. Now, in order to do that, I first am going to need to label and scale my axes. As a convention, we like to call the x-axis the horizontal piece. Hang on one second, my coordinate got off just a little bit. Let me line that up again. That's a little bit better. Oops. Let me group these. So, and I want to group these together. Okay. So, I want to call the horizontal axis the x-axis, again by convention, and the y-axis will be the vertical axis. And in order to scale my axes, I need to look at my points. The farthest distance I get away from the origin is this 4.5 right here. This piece is the one that's farthest from the origin, so I need to make sure I can go out at least 4.5 units. Now I could label each of these by 1, but then I would only be using about this much of my graph, and that just seems like a waste. So what I'm going to do is, if I were to go by 1/2, so each of these little tick marks is worth 1/2, I would be able to go 1, 2, 3, 4, 5 units, which is perfect. I need to go out 4.5. So what I'm going to do is I'm going to label, I just need to label one of these x pieces, and I like to label my 2's. 1's tend to fade in with the graphs, and 2's stand out a little bit more. So what that's saying is, right here on this tick mark, I'm out 2 spaces, which would imply that right here I'm at 1, and here I'm at 3. On the y-axis, I could label a different scale if I wanted to. However, I like a square axis as much as possible. So I'm going to also label a 2 here for my y, implying here is 1, here is 2, here is 3. The same will go with the negative sides of the axes, but I don't need to lay them in. If I've labeled this as a distance of 2, then I know that that will map all the way through. I have to be consistent with that spacing. So now I want to plot these points. I'm going to plot this first point, and I'll call it red. So in red, I'm going to plot this first point. It's at 3.5. So 1, 2, 3.5 right here. That's the x-coordinate. And then it's going to go up 4.5. 1, 2, 3, 4.5. It'll be right here. So that's that first point. 3.5. Make that a comma. 4.5. And what quadrant isn't that in? Well, that one is in quadrant 1. The next one that I will label, I will do in green. It'll be -4, 1, which means I'm going to go -4 in the x direction. 1, 2, 3, 4. Then up 1 in the y. And this is right there. -4 and 1. And he is in quadrant 2. I will mark the next one in blue. I like to color coordinate these just so it's a little bit more visually clear what's going on. This is at 0, 3. It means I haven't gone left or right at all. So I'm only going to go up 3. This point lies on the y-axis. 0, 3. He's not in a quadrant. He's on the y-axis. The next point will be 3, -2. +3 in the x direction, and down 2 for y. The point 3, -2. And this point is in quadrant 4. The last point I will mark in black. It's the point -1, 0, which means I go negative in the x direction. And then I don't go up or down at all for y, so that point is right here, -1, 0. Again, it doesn't live in any of the quadrants. It is on the x-axis. Now, all of these points are written in a way that we call ordered pairs. Why do you suppose we do that? Well, there are pairs of numbers, and they are always written in the same order. me try that again. Specific order. And that order is x and y. We always list the horizontal component before we list the vertical. We want to know how far left or right we go before we talk about how far up or down we go. And this will always be the way it works when we're graphing ordered pairs. So now that we know how to graph things on a coordinate system, I want to talk about solutions to equations in two variables. The first question we want to talk about is what would make an ordered pair the solution to an equation? And if I have an equation, just something with two variables and an equal sign, in order for an ordered pair to be a solution to that equation, if both variables are plugged into the equation, the equation is a true statement. In other words, the left-hand side equals the right-hand side. So let's just try it a couple times. I want to find out if the following ordered pairs are solutions to the given equation. Now, how I like to show this, I like to specify that I am plugging variables in. So let's pick a different color. I'm going to show that I'm plugging the 1 in for the x and the 4 in for the y. How I do that is I copy down the 2. The x I'm going to put, I'm not going to put an x, but where the x is, I'm going to put a set of parentheses. And then plus parentheses where my y was. And we're trying to find out if this equals -6. I like to put the question mark above the equal sign. It just helps me remember that I'm checking for equality. And then in this first set of parentheses, I'm going to put the 1 for the x. And the second set of parentheses, I'm going to put the 4 for the y. Now, when I look at this turns into 2 times 1 is 2 plus 4. That equals 6, not -6. So since 6 does not equal -6, this is not a solution. I'm going to try the same thing for the second equation. 2 times 0, well that's 0, plus a -6. Does that equal -6? Well, 0 minus 6 does in fact equal -6, so that one is a solution. For this last one, 2 times -1 plus a -4. Does that equal -6? Well, 2 times a -1 gives me a -2. Plus a -4 is a -4. That does in fact equal -6, so yes. Notice that there were 2 different ordered pair solutions to this equation. How many ordered pair solutions are there? This is a line, so there are infinitely many ordered pairs that are a solution to this equation. How could I find another one? We'd have to pick one variable value and solve for the other one. So for instance, I could let x equal and I could pick any number I want to. It's not helpful to use 1, 0, or a -1, but I could try something else. I could try maybe 2. If I let x equal 2, then I end up with 2 times 2 plus, and I still don't know my y value, equals -6. Now notice I almost forgot my negative sign there. You will probably do the same thing every once in a while. I'm going to do just a little bit of algebra here. 2 times 2 is 4. 4 plus y equals -6. And I need to isolate that y value, so I'm going to subtract 4 from both sides. And I wind up with y equals -10. So another solution to this equation would be the ordered pair 2 and -10. That's how we would find another solution. I'm going ahead and pause here. I will start another video for the other slides in this section. This way you can take a break, get to work on some of the questions, and then come back for another chunk.